So very good morning students. This is data representations. So this is the fourth category. In previous video I just explained only floating point, that is floating point representation. Now we shall discuss other decimal codes. This is one of the data representations in any computer. First, what is other decimal codes? What are the other decimal codes? Before the decimal codes there are 9 numbers, that is 0. There are 10 numbers 0 to 9. The base of the decimal number is 10, so 0 to 9. Then other decimal codes, the first one is BCD. This is very popular one, very popular code. The name is BCD, or it is also called 8421 code. What is 8421? So 8421 indicates the binary weights of the 4 bits. So there are 4 bits are there for decimal 0. So decimal 0 is represented as in BCD form 0000. There are 4 bits. So each 4 bits have its uh, each 4 bits have its separate in its separate weight are there. So that is 8421. So 0 is represented as 000. All the 4 weights are 0. 1 is represented as 001. So the only weight is presented for 1. So that's why the decimal 1 is 0001. Then 2, 0010. So 2 is presented. So the weight is called 2. So the 4 bit, the decimal 2 is equivalent BCD 0010. Then one more for 7 for decimal number, which is equivalent BCD is 0111. Okay. Similarly for 8 is 1000. So only the weight 8 will be presented, all other 3's are 0. So this is known as BCD. So BCD or 8421 code. Otherwise, sorry, next one 2421. So this is also a weighted code 2421. The weights, each 4 bits, sorry, each bits are indicate its binary weights, that is 2421. The next one 84 minus 2 minus 1. These are also called weighted code numbers. Then XS3 code is not a weighted code numbers. Then XS3 directly added to the BCD plus 3 is known as XS3. BCD, that is binary coded decimal, plus 3 is known as XS3 code. So already the BCD is there in second column, that is 000, which is added to 3. So every number which is added to 3, the result is called XS3. So 3 will be added, so 0011. Okay, similarly for 001 it will added by 3, so 1 plus 3 is 4, so 0100. So likewise we can add all the bits, all the BCD bits plus 3, it's called XS3. Okay, so here one conclusion is BCD 2421, 84 minus 2 minus 1, these 3 other decimal codes are called weighted codes. Only the XS3 code are non-weighted codes. The next code, go to next. The next gray code. So gray code is also a unweighted codes. Gray code is not a weighted code. So first, what is gray code? So gray code is another important code that can be used in sequence counting. That can be used in sequence counting. What is sequence counting? Suppose in previous page, that is a gray code for 3 columns. Here there are 3 columns. One is decimal number, another one is a gray, another one is a binary. Now the decimal numbers for 0 to 15. its equivalent binary, that is 4-bit binary, is then the third column 00021111, which is directly converted to gray. For 0 is for all the 4 bits for 0 is converted to gray as 0000. 001 is converted to binary, that is binary to gray, that is 0001. The next 0010 for 2 for its equivalent decimal is, but the binary is converted to gray, that means 0010. How it is changed? 0010, that is 0011, it's changed in 0010. That is uh, there are two definitions are there in conversion for binary to gray. The most significant bit of gray code is same as most significant bit of the binary. The first bit, that is the most significant bit, leftmost bit, that is the first bit, as take as it is for the gray code. Then next, second point, coding from left to right. Coding from left to right, add each adjacent pair of bits to get the next bit of the gray code. That is second bit. How to calculate the second bit of the gray is coding from left to right, that is start left to right, add each adjacent pair of bits, add, add each adjacent pair of bits to get next bit of the gray code. Suppose if it occurs any carry, to omit. So this is two, these are all the 2 points for converting binary to gray. For example, now I am taking the binary for 3, that is 0011, which is converted to gray. That means the first bit as it is, that is the most significant bit, you take 0, so the first bit is 0. So how to calculate the next bit of gray is, that is leftmost bit, to add the pair of bits, that is 0 plus 0 is 0. So next 0 plus 1 is 1, that is the third bit. The next 1 plus 1 is 1 0. So here you take resulting bit only, the carry bits are omitted. Similarly, can convert all the binary bits equivalent to gray. So this is gray code. The next, gray code also called reflected binary code. What is gray code? Is also called a reflected binary code. So how it is called? The gray code is reflected binary code. There is some reasons are there. Uh, in previous page, for reflecting, that is you take the second, that is the third row, the 1110. Then similarly for fourth is 1011, this is called reflecting, that is mirror reflecting. 10, that is 1110, after that 1011. Likewise, uh, 0100 similarly 1110, the next 1011. So least significant, that is LSB for 2 digits are reflected uh, alternatively, that is starting bit for 00, then 01, that is here 00, then 01. Similarly for 1110, then 1011. Likewise you can reflected uh, all the bits. That's why the gray code is also called a reflected binary code. Okay, next, ASCII. So ASCII, the full form of ASCII is American Standard Code for Information Interchange. American Standard Code for Information Interchange. Also it is called a 7-bit code. 7-bit code. So 7-bit means the range of ASCII, that is the possible binary combinations is 2 power 7, which is equal to 128. 128 binary combinations are there in ASCII because of it is 7-bit code. Okay, so these are all the some character representations in ASCII. The next, the character, the the character representations as it controls some all the characters all the characters are represented some controls. First one null, null, that means null. The control is null. SOH, the full form of start of heading. Similarly for ETX for end of text, STX for start of text. So these are all the some controls for handling the ASCIIs. So CC is for communication control, that is format effector, FE, IS for information separator. So all the characters, so it should be control some uh, keys. Okay, so this is ASCII representation, character representation. Go to next, error detecting course. So error detecting, what is error detecting? So it detects the errors out these codes, that is error detecting codes detect the error when it's occur errors, that is if it is occurred during transmission of original data, that is bit stream. Suppose if you want to transmit a original data, on the time it occurs error. So how to clear this error? There are several examples are there, that is several codes are there. One is parity code, another one is hamming code. Now we just see only the parity code for detecting the error. So there are two parity codes, one is odd parity, another one is even parity. That is parity means the parity bits can attach one extra bit for detecting the error. That is odd parity or even parity. Suppose we take one uh, the first one, even parity. Even parity. So even parity bit should be 0 if even number of ones present in the binary code, otherwise it should be 1. So this is the condition. What is even parity bit should be 0, that is all the bits are 0, that is for even, that is 0 0 0 0. That you take 3-bit binary, that is 0 0, the bits are odd, that is 0 is odd. Now you can add the extra bit, that is 0. So the the bits are converted as even number of zeros, so the errors are automatically detected. Similarly for 1 0 0, here the number of 1 is odd, so you can add for last bit, that is LSB, for add 1. So 1 0 0 1, so now the now number of 1 is even, so automatically it converts even parity. So here one example